Hello everyone and welcome to Beginner's Code, a place for you to learn with me as I dive deeper into the coding world. Before I start, if you haven't yet, please check out my new website for blogs all about Python. You can also look at my posts on Instagram that go into detail about the basics of Python, or if you're looking for source code for some projects, then by all means check out my GitHub where there are almost 70 projects that you can explore. The links for these will all be in the descriptions below, so please do check them out. Also, don't forget to subscribe to see more videos from me as I teach you through the basics of Python. Okay, so in today's video we are going to be looking at the different kind of data types that come with Python. Now there are quite a few, but to start with we will look at numbers. Now numbers consist of two different types. We have an integer, which is a whole number such as 10 or 2, and we have a float, which is a decimal place number such as 2.45 or 6.45. Now we can, if I just comment these out quickly, we can call different mathematical operators on different numbers. So if I was to do print 10 plus 4, we should return 14, which it does down here. And then if I comment that out and print 10 plus 21, we should return 31, which it does. Now we can do exactly the same with subtraction, and this is just the minus symbol. So if we do print 10 minus 4, we get back 6, and we can also do it with floats. So if I do 10.2 minus 2.3, we get back 7.9. Now to multiply, it is just the asterisk symbol, which is above the 8. So if we do print 10 times by 4, we should get back 40, which we do, and we can also do it with floats, so 2.3 times by 2, which will return 4.6. Now to divide, we just use a single forward slash. So if we do print 10 divided by 2, we will return 5, which it does just down here. And we can do exactly the same with floats, so 10.2 divided by 5, and that returns 2.04. Now for floor division, this basically is two forward slashes, but what it does is it takes the second parameter and see how many times it can go into the first parameter. So if we were to print 21 floor division 5, this will return 4 because 5 goes into 21 4 times with 1 left over, which it does, 4. To make this a little clearer, if I do 10 floor 2, this should return 5 because there are no remainders. 2 goes into 10 5 times. And you see down here 5 has printed. Now the modulus operator is the percent sign, and this works the same way as floor division, but instead of returning how many times it goes into a number, it returns the remainder. And this is perfect for trying to work out even numbers and odd numbers. So if I do 10 mod 2 and run this, it prints 0 because there is nothing left over, which means that it's even. And if we were to print 11 mod 2, we will get 1 left over. Now, with the asterisk symbol, we can also use it for powers, but this time we will use 2. So if we do print 2 to the power of 2, this should return 4, which it does just down here. And if we do 2 to the power of 3, this should return 8, which it does. So we can also use the power symbol to work out square roots. So if I was to do print 16 to the power of 0.5, this will return the square root of 16, which is 4. We can also use brackets to determine or specify which operator we want to happen first. So if I was to print 10 plus 6 times by 4, and run this, we get 34. But if I was to put brackets around 10 plus 6, it will make it 10 plus 6, which is 16, times by 4, which is 64. We can also do the same with other mathematical operators. So if I was to do 27 minus 3, and then divide by 12, this should return 2, because 27 minus 3 is 24, 24 divided by 12 is 2. Okay, so now the next thing we will be covering is variable assignment. So what this is we can assign a variable which can be named anything you want to a specific number. So if I was to make one called num1 and put that equal to 12, and then num2 and put that equal to 4, we can then print num1 plus num2. And if I run that, that returns 16. Now, when you're assigning variables, you want to make it as clear as possible, because if someone else comes and looks at your code and you have this as A and this as B, and then you do print A plus B, it doesn't look at or make as much coherent sense as it may do if you had money in and money out, and then you did money in minus money out, and that would return 8. So it doesn't matter which way around you do it, but as long as it makes coherent sense and the variables are named something that actually does correspond to what your script is about. Now, we can also do reassignment. So if I was to use num1 and make that equal to 4, then here, if I was to do num1 is equal to num1 times by num1, so what we're doing here is creating a variable called num1 and making it equal to 4 times by 4. And this will reassign the variable num1, so the next time we print num1, it will just print the answer of 4 times by 4, which is 16. Okay, so the next data type we are going to be speaking about are strings. Now, strings are a series of elements that create up a phrase or a word or a sentence. And what I mean by this is if I was to type in print and then create quote marks and type in hello world, now this is a string. As long as it is enclosed in double or single quote marks, it is considered a string. And if I run this, we get hello world. Now, what I can do just to change this is put single quotes here and run this, and we will get the same output, hello world. Now, if you are using apostrophes within your sentence, there is a very easy way to get around this, and that's just by using double quotes. So if you were to type in she's a coder and run this, it will print out with the apostrophe. Whereas if I was to use single quotes and type in she's a coder, you'll see that the color has actually changed, and if I run this, we will get an error saying invalid syntax. So you can also do exactly the same with quote marks. So if you were typing in something that actually contained a quote from someone, then you can type in single quotes and put double quotes inside of the single quotes and put hello, he said. And if I print this, then it will run with the quote marks actually there. Now, another way to get around this is actually using escape characters, and an escape character is a backslash. So what we could have done is type in print she's backslash apostrophe a coder, and this will run exactly the same as using double quotes around the apostrophe. Now, escape characters can also be used to create new lines or to create tabs in the words. So if I was to put in a escape character and then put T, I can then type in hello world, and you will see this is actually tabbed over on the output. So this creates more space and can actually make it a lot more attractive when you're typing, but can be used for certain game methods. Now, we can also type in hello \n world, and this will put things onto a new line. And this is very useful because if you ended this with a \n, then it will actually create a new line as well. And this is very, very useful for making sure your output is contained within where it's meant to be and not too cluttered for the user. Now we can also use a length function which comes built in with Python. So if I was to type in print and then len, which stands for length, and put in hello world, exclamation mark. Now the length function will count every single character inside of the quotes, including a space and punctuation. So if I run this, we will get 12 back. Now, as I said earlier about strings being a list of sequences, what this basically means is we can grab a specific character from the string as long as you know which index this is at. So what we can do is assign a variable word to hello world, and if I was to print word and then use square brackets and put 0 and then run this, we will get H. Now if I was to do exactly the same and change the change the 0 to -1, we will get the final character, which is D, and you can see there D has outputted. Or I could do exactly the same and put in, say, 7, and this will return O for the O within world. Now remember, indexing does start at 0. We can also use the square brackets to slice a word, and this basically means to get certain characters of the word. So what I can do is 2:8, and this will return from the second character, which is the L, because it starts at 0, so 0, 1, 2. So we will get L all the way back through up to, but not including, the 8th character, which will return this random concoction of letters. Now we can also use this to reverse strings. So if we have 2 colons, this then uses a step size, and what a step size means is it goes through the word by the different amount of steps. So if I did 2, for instance, it will go through the word starting at 0 and grab every second index. So if I run this, we get back this string, and if I do the same and put -1, this will actually reverse the string, and we will get the string here outputted but backwards. Now, one thing that you need to know about strings is that they are immutable, and what this means is they cannot be changed. Once it's defined, it cannot be changed. So if I was to type in word 0 and try to assign that to the letter L, this will not change, and it will give an error saying object does not support item assignment. Now, one good thing about strings is that we can use them to concatenate. And what this basically means is if I create a print statement and I put word plus and then space from beginner's code, and I run this, we get back hello world from beginner's code. Now, there are certain methods that we can use on strings. So if I was to do print word dot, this will bring up a list of lots of different methods that we can use. So for example, if I type in upper and then use open and close parentheses to call the function or the method and run it, we get hello world back all in uppercase. Now if I do the same for word.lower and call it, we can then get exactly the same back but all in lowercase. And we can even use the split method and pass in a parameter of space, and this will return a list of everything that has been split by the space. So here we have hello space world, and this will return a list of hello and world. So if I run this, we get 2 items back in this list. The first one is hello, the second is world. And to show how this would change, if I did from beginner's code we will get 5 items back in the list, and I can even print the length of this. So we will get back 5 because there are 5 different words that have all been split by the space. Next, we are going to be talking about Booleans, and Booleans basically are either true or false, and we can assign them to a variable, so true, and then if I was to print this variable, we get true. We can also change it to false and print the variable again, and we get false. Now, Booleans are extremely useful when it comes to while loops and if statements, and also comparison operators. Now, comparison operators is something I'm going to be going into more detail in soon, but for example, if I was to do 4 is greater than 3 and print this, we will get a Boolean back of true because 4 is greater than 3. So when it comes to if statements and while loops, the comparison operators are usually used to make sure that something will run while it's true. Okay, next we have lists, and lists are extremely useful in Python. They are able to contain a multiple amount of different data types. So to create a list, what we do is use square brackets to open and close, and each item needs to be separated by a comma. So if I wanted to print the lists, or this list, we can print, run, and we will return exactly the same. But if I wanted to change this to, say, hello, and this to true, we can then print the lists, and we will also get the exact same back, but with a string and a Boolean included. Now, this can be very, very handy when it comes to different data types and having databases and using them all in different ways. Now, one thing that we can do, just like strings, is use the length method. So if I print the len of lists, we should return 6 because there are 6 different elements, 1, 2, 3, 4, 5, 6. And just like with strings, we can also use indexing and slicing. Now, lists also start at 0 when it comes to indexing. So what we will do is lists, or print lists, and then open and close brackets with 0. And this will get the first item, which is 1. So if I print this, we will get 1. If I comment this out and then do print lists -1, we will get the Boolean of true. And then if I wanted to slice and get the second and the third, so we will get 0, 1, 2. So we will get 2, 3, up to, but not including 4. So we will get 3 and 4 back in a list. And if I run this, 3 and 4 as a list. Now, just like strings, we can also go through with step counts and reverse them if necessary. So I will just quickly show you that. And we get this list reversed. Now, one thing that is different between strings and lists are the fact that lists are mutable. So what this means is if I was to take the lists variable and get the index of 0, I can reassign the index 0 to a completely new number or piece of data. So if I wanted to change the index 0 to the number 9 or the integer 9, I can. And then if I print lists, you will see that 9 becomes the first one, and then 2, 3, 4, hello, and then true. Now, one thing that is very cool with lists is we can actually print them multiple times. So if I wanted to, I could use the mathematical operator of multiplication and times the list by 2 to get the list printed twice. Now, this isn't a permanent thing. if I were to print lists straight after, we only get the first one back. However, if I were to create a new list called new_list and assign it to that and then print new_list, we will have a new list created that can be accessed with the duplicated data. Now, there are lots of different methods that can be used with lists, but the first one we will use is append. So if I have lists.append and then put end at the end. Now, you don't need to print this, but I will show you that if you do, you will return a none value, which basically means that you're getting none because there's nothing to return because it has appended. So if I remove the print method and then print lists, you will see none, you will see end at the end of the list. Now if I comment this out and I also comment this out, we can also create nested lists. So if I wanted to, I could do list_1 is equal to 1, 2, and 3. And then list_2, oh, there's no equal there. List_2 is equal to 4, 5, and 6. And then list_3 is equal to 7, 8, and 9. Now what I can do is do nested_list and create a list of list1, list2, and list3. And then if I print the nested list, you will see here that there are lists inside of lists. Now, you can also use indexing and slicing on this. So to get this, I would be doing nested list. And if I wanted just the first list, which is list 1, I would use 0. So if I print this, you will get 1, 2, and 3. If I change this to 2, we will get list 3, which will be 7, 8, and 9. But if I wanted to get specifically the number 7, I would then do the second index, because list 3 is the second index, and I want the first index of list 3. So it will be 2 and then 0. And if I print this, we will get 7 back. Okay, so the next piece of data we're going to speak about are tuples. And tuples are very useful. They are extremely similar to lists, however they are immutable, and I will show that in a second. Now, if we create a tup variable and assign it to open and close parentheses of data of 1, 2, 3, and 4, and then if I print tup, we will see down here in the terminal 1, 2, 3, 4 has been returned as a tuple. Now, we can also change the data types just like a list to contain strings, booleans, even another list or another tuple if we wanted to. So now we can also, just like with lists and with strings, we can also find out the length using the length method. So if we put in len and then the variable and print that out, you will see 4 because there are 1, 2, 3, 4 pieces of data. We can also use indexing and slicing, and indexing and slicing is extremely easy with tuples as well. All we need to do is print the tuple with the index. So for now we are going to retrieve index 0, which is the first one, which is number 1, which will return 1. Now if we wanted this string, we can do -1 and we will return hello. We can also slice exactly the same way. So if I put in tuple and then put in 0 through to 2, so we will want to get back 0 and 1 because it's up to but not including, so that will return 1 and 2. Now we can also reverse just like with strings and with lists. So tup and using the step size of -1, this will return hello 321. Now, I said a minute ago that tuples are immutable. Now, if I wanted to reassign the first index of the tuple, so if I wanted to reassign 1 to being a string of beginning, then this will throw an error saying type error tuple object does not support item assignment, which means that they are immutable, it cannot be changed. Now this is the big difference between a list and a tuple. Lists are often used when you know for sure that you are going to keep changing data, and sometimes lists are used even if you're not 100% sure, because you might come across a time that you do need to change a piece of data. But tuples are used when you know for sure that you will not be changing data. Things like days of the week or minutes of a football game. Now there are different methods that can be used. So if I wanted to print the tuple.index, I can find a specific index. So if I wanted to find the index for hello and print that, then we will get 3 because it is the 0, 1, 2, 3rd index. Now we can also do count. So if I was to do print tuple.count and then 2 and print that, you will see the 1. But if I add another 2 up here and then run it again, you'll see it's changed to 2. So the .count just counts the amount of times this parameter is found within this variable. The next data type we're going to speak about are sets, and sets are very similar to lists, however they don't support indexing and slicing. So to create a set, we can just create a variable, we'll call it set1, and this uses the curly braces. So if we create 1, 2, and 3, and then if we print set_1, this will print the set of 1, 2, and 3. Now, one thing that is very, very crucial about sets is it doesn't show duplicated data. So if I was to put in another 3, and then a 2, and print the same, we will still get 1, 2, and 3 inside of this set. We can then also use the length method on the set to find out how many different pieces of data there are, and in this case, because it doesn't show duplicated data, it will only return 3. If I comment that out and comment that out, we can then also use set_1.clear as a method, and this will then clear the set and will return an empty set. We can then also comment that out, and I will comment that out. If I do set_1 is equal to an empty set, and then set_1.add and put in 1, and then do set_1.add and put in 2, and set_1.add and put in 1 again, we will get back so that's actually turned it into a dictionary, so which we will be going on to next. So if I create a set of 1 and 2 and then add it, it will only show 1 and 2 the ones. Now, one thing that sets are extremely good at is casting. So if we had a list of random numbers, and I'm just going to neaten this up, and then if we wanted to cast the list as a set, we can do set list_1, and we can print this. And printing this will return 1, 2, 3, and 4. It will only show how many times the duplicated data, or how many times the data is shown for the first time. We can then also, we could even turn this into a variable. So new list is equal to set of a list1, and then if we were to do print length of new list, we will then return 4. So the final piece of data that we are going to be showing you is the dictionary. And dictionaries are extremely useful in Python. They come with key value pairs and are used for a wide range of data. Now, to create a dictionary, we can create a variable and assign it to open and closed curly brackets. Now the first piece of information we'll type in is the key, and then a colon, and then value. So these two are connected to each other in essence. Now if we were to print D and then open and close square brackets followed exactly by the key that's written up here, we can run this and we will get the value back. Now if I was to change this to key 2 and then put key 2 down here and run it, we get exactly the same back. So this has to be the same as that. Now I'm going to delete that and add a second key. So now we have key 2 and a value of 54, and then key 3 and a value of true. So now if I wanted to get or retrieve this integer here, I can put in key 2 and we will return just the integer here. Now what we can also do is call specific methods on a specific value. So if I wanted to do print D and then have key dot lower, because this value here is a string, then actually I'll change this to upper because it is already lower. So if I change that to upper and run it, we get value back in uppercase. Now we can also change or affect the number or integer that is already placed or assigned to a key. To do this, we can do key 2 is equal to D key 2 minus 50, and then if we print D key 2, what this is essentially doing is you're reassigning the key 2 of this dictionary to be this value minus 50. So what we should get in return is 4. And we do. So if I comment that out, and I'm also going to comment this out, and we can then create a new dictionary in a totally different way. So to do this, we can create a new variable and open and close curly brackets and leave it as that. We can then do D and create the key of, say, animal, and assign it a value. We can then do D age and assign it a value, and then breed and also assign it a value. So what we would be doing here is printing this whole dictionary, which will return an unordered dictionary of these values, or these key value pairs, sorry. So what I mean by unordered is if I press run, you will see here that animal was actually the first one entered, but animal is the last thing here. It's the last one in the dictionary. Age is the second, but it's actually the first that's returned. And breed is the middle one. So what this means is whenever dictionaries are created, they are unordered and they are random. So when you call them, they will be brought back as different, in a different order. So one way to go around this is we can call specific methods for getting a specific value. So if we wanted to just return all the keys, we can do print d.keys and then run that, and we get all the keys, so age, breed, animal. And if you were looking for the animal, you could then do print d animal and run that, and it will return dog. So I will just delete that, as that was just for show. We can then also do print d.values, and this will return all of the values here. So we should see dog, 13 and husky. Yep, a list of them. And then finally, we can also do d.items. Now d.items will show a list of tuples, and to get around this, we can then do tuple unpacking, which is something I will be speaking about at some point. But you'll see here that age and 13 have been returned as a tuple, but all of the information has been returned in a list. Now, finally, I'm just going to comment that out. Finally, we are going to speak a little bit about nested dictionaries. Nested dictionaries are very, very difficult to get your head around for beginners because they can go very deep, but I wouldn't suggest using them as often because other coders get very annoyed with it. So you can create your own dictionary with a key, and then the value will be another dictionary, and this will hold another key, and we could even go as far as adding a third dictionary, a third nested dictionary, or a sub-nested dictionary, which will have the value or the key as sub-nested, and then a value of value. So to get this back, and it does look a little bit dodgy, we can do D key, and then using the open and close square brackets again, we can add in this key here, so nested key, and then doing exactly the same, we can add sub-nested. And if we were to print this, we should get the value back. And we do. Now that's all for today's video. You should now have an understanding into the different data types of Python and how they can be used. These are the fundamentals that all scripts will use, so make sure you have a strong understanding of them. If there are things you're unsure about or that you'd like me to cover further, please don't hesitate in reaching out to me by dropping a comment below on Instagram or through my website. Stay tuned, as in my next video I will be showing different ways of coding a dice simulator. If you liked what we've been through today and you want to learn more, please drop a like and subscribe to my channel to keep up to date. Thank you and see you next time.